Hey there, welcome to another edition of Kung Fu Physics. We are working our way through practice physics GRE problems, and today I have another mechanics problem for you. It's number 74 off of the 1992 exam. Looks like this. And we'll go right into it. Quick glance at the answers. Just has something called T divided by some constant. So let's read the text of the problem. Number 74, two circular hoops, X and Y, are hanging on nails in a wall. The mass of X is 4 times that of Y, and the diameter of X is also 4 times that of Y. If the period of small oscillations of X is T, the period of small oscillations of Y is... So one of the first things that I think is useful in doing this problem is just making a quick drawing. So I'll draw in the hoops. That's X, and I'm going to say that the mass of hoop X is 4m, because we were told it was 4 times as heavy. And then I'm going to call this radius here. This is the radius of hoop X. I'm going to call that 4r. Because, and the reason I'm using 4 there is because what I'm going to do is draw in hoop Y here. And then I'm going to call the radius of Y R. And of course the mass of R N. And so I tried to draw that in there so that it's accurate to the problem. Basically, I'm trying to represent this as being 1/4 of the diameter of this one, or this is 4 times how it describes in the problem. Of course, that means it's the same for the radius, right? If the diameter is 4 times as big, the radius is also 4 times as big, correct? So a quick picture maybe will help you. It does take a little bit more time, so it's open for debate whether that's useful to you or not. Useful to me, I think. So from there, I want to get an equation, because what it's asking about is the period of this physical pendulum. And there are other physics GRE problems that use this. I've posted 1 or 2, I would say, where you have to know about physical pendulums. The equation that I think is worth committing to memory for the period of a physical pendulum is this. T equals 2 pi times the square root of I divided by mgd. I wrote mgh there by accident. It's 2 pi times the square root of I being the moment of inertia divided by m being the total mass, g gravitational constant, and d being the distance between the pivot point and the center of mass of the physical pendulum. I think this one is worth committing to memory. So what I'm going to do here is divide my board up into 2 sections, and I'm going to put the hoop we're calling X on one side and the hoop we're calling Y on the other side, like this. And then I'm going to see what the period looks like for the both of them. So I'm going to call this the period of X, and so we're going to go down from here. So what will the moment of inertia of X be about that nail? Now, you use parallel axis theorem for it, and it's basically in parallel axis theorem you take the mass of the hoop times, okay, let me say that again. You take the moment of inertia of the hoop around its center of mass. And so in this case, for the big hoop, that's 4m times 4r squared. That's the moment of the hoop about its center of mass. And you add to that, you treat the hoop as a point mass. you shrink it down and you add the contribution it would make to the moment of inertia if it were like a point mass. And if you don't understand why you do that, then review parallel axis theorem, because you will use that. I ran out of space there. Oops. You will use parallel axis theorem other places on the physics GRE. Definitely know that. For the case of a hoop, it happens to be the same. Those two factors look exactly the same, but that's just a single case exception there. Okay, so the total mass of hoop X is 4m. We just have G, and then we have D, and that's going to be the distance between the nail and the center of mass, which is also 4r. So stuff cancels all over the place. The mass cancels. One of these will cancel. And you are left with T sub x equals 2 pi square root of 4r over... Sorry, I did that wrong. See, potentially you could make a mistake there. I'm adding 4r plus 4r. So I should have 8r there, right? 8r over g. Okay, so T sub y, we do the same thing, and it turns out to be quite a bit simpler. I'll just write that again to be consistent. Okay, so what is I for T sub y? Well, this is just m r squared. It's going to be exactly the same because it's a hoop, right? Just instead of those 4s, I get just m's and just r's. And then again, stuff cancels all over the place. It cancels in the exact same manner. And I get 2r over g. Okay, so there you have it. Those are the two periods of these two hoops and what they look like similar to each other. Now, you read very carefully. The problem is telling you that this is equal to t. And if that's so, what is this? And so the best way that I can see to get from there to there is to say, all right, well, I'm going to erase this. That's equal to t. I want to manipulate this so it looks like this. So what is this? Well, this is just 4 times 2r equal to t. Okay, now I can factor that 4 out. I get 2 pi times 2 over g equals t. And then I just divide by 2. And I get this equals to t over 2. And that is equal to t sub y that we have over here, right? That makes sense? There's a lot of places where you can get off track and make silly mistakes on this problem doing it this way. But that would lead us to an answer. That would lead us to answer B, t over 2. I would love to get any input and feedback people have on this problem, because the way I've done it here, as I've said, it's a correct way. It's a right way to do it. It's a legit way to do it. I did look at some of the posted solutions at some of the other places on the internet that post physics GRE solutions, and some of them are a little vague on this problem. But I honestly think that there might be a faster way to do this problem than the way that I just spelled out to you. And I'm curious if somebody has a significantly better way to do the problem. And as always, with any of these problems, if you do, or of course if I make some glaring mistake, leave a comment or send a message or post a response video, anything like that, and let me know. I would be curious if there was a faster way to do this problem, because the way the problem's laid out now, you know, I would put it in the realm of being a moderate to difficult problem, in that there are a lot of places you can make a mistake on it, and it seems like it's really easy, but you actually have to do enough to be a hassle. So if there's an easier way to do it, I'd love to hear about it. Otherwise, that's what I got for you on number 74 off of the 1992 exam. As always, thank you for watching. See you next time.